Welcome to the Advanced Software Architecture course. My name is Michel Chaudron, and this is the lecture Documenting in UML, Part 1. This lecture contains a series of topics that will help you to understand the main concepts and notations for documenting software systems. The main focus will be on the so-called 4+1 views paradigm. This model is designed by Philip Cruchten for describing the architecture of software-intensive systems based on the use of multiple complementary views. In the lecture, first we will introduce the concept of architecture documentation and the 4+1 architectural view model. This will be followed by the presentation of the most important diagrams for describing software architecture from these different perspectives. Most complex specifications are so extensive that no single individual can fully comprehend all aspects of the specification. Furthermore, different people have different interests in a given system and different reasons for examining the system's specifications. A view of a system is a representation of the system from the perspective of a viewpoint. This viewpoint on a system involves a perspective focusing on specific concerns regarding the system. This view suppresses details to provide a simplified model having only those elements related to the concerns of the viewpoint. The purpose of views and viewpoints is to enable humans to comprehend very complex systems, to organize the elements of the problem and the solution around domains of expertise, and to separate concerns in different views. For example, different stakeholders involved in the building of a house focus on different concerns regarding, for instance, the inner structure of the house, its electrical or plumbing plan. Therefore, different models of the house are created in order to present different aspects of the house being built. And as a building architect might create wiring diagrams, floor plans, and elevations to describe different facets of a building to its different stakeholders, such as electricians, owners, or planning officials. In a similar way, an IT architect might create views for physical and security views of an IT systems for different stakeholders who have concerns related to different aspects. Documenting a software architecture involves choosing and documenting the relevant views of that architecture and then documenting information that applies to more than one view. The relevant views are the ones that best serve the needs of the architecture documentation most important stakeholders. Different views often support different contributions with respect to a system's quality attributes. For example, a safety or a security viewpoint focuses on security concerns, and a security viewpoint model contains those elements that are related to the security from a more general model of a system. By contrast, a view showing how the same system is structured as a set of communicating processes can be used to engineer and analyze certain kinds of safety issues into the system. A view that shows a system structure can be used to engineer certain kinds of maintainability into the system. And thirdly, some other stakeholders could be interested mainly in the performance of the system. Therefore, they should be presented with a view showing parallelization of the certain processes within the system. Architecture views are representations of the architecture that are meaningful to one or more stakeholders in the system. The architect chooses and develops a set of views that will enable the architecture to be communicated to and understood by all the stakeholders and enable them to verify that the system will address their concerns. An architecture is usually represented by means of one or more architecture models that together provide a coherent description of the system's architecture. A single comprehensive model is often too complex to be understood and communicated in its most detailed form showing all the relationships between the various business and technical components. As with the architecture of a building, it is normally necessary to develop multiple views of the architecture of an information system, to enable the architecture to be more easily communicated to and understood by the different stakeholders in the system. The concept of views and viewpoints has been developed to organize the information in an appropriate way for the various perspectives needed by the stakeholders. Views abstract away information that is not relevant to a particular viewpoint. Documenting a software architecture involves documenting multiple views of an architecture. No single structure should be considered to be the architecture, but the many structures together compose an architectural model. Organizing the description of a system in multiple perspectives is a way to make the description easier to create, easier to understand, and easier to maintain. The 4+1 view approach is one specific approach to organize a system's architectural representation into views. Globally, this approach organizes views in two dimensions: a more conceptual dimension and a dimension that deals with more tangible, physical artifacts of the system. Let's go over all of these views. First, there's the structure view. The structure view is concerned with the grouping of functionality of the system. The UML diagram that can be used to describe the structure includes a component and class diagram. Next, there's the behavior view. The behavior view deals with the dynamic aspects of the system. One perspective of behavior is the flow of information between system components. This perspective is typically described using sequence diagrams. Another focus of behavior can be on behavior that is part of individual components. For describing this, typically state diagrams are used. And a third aspect of behavior, for example one that is common in information systems, are business processes. This type of behavior is normally described using activity diagrams. Also, the behavior view can be used to describe concurrency aspects. And together, the models in the behavior view support the analysis of performance and scalability. The next view is the development view. The development view describes how code is organized during the software development, such as the mapping of conceptual components onto actual files in directories. And also the development view addresses the policies for build and version management of the code. The fourth view is the deployment view. This deployment view is concerned with the topology of software components and their physical distribution, and also it addresses the network connections between these components. The UML diagrams that can be used to represent the deployment view include the deployment diagram. And finally, there's the fifth view. It represents the +1, and this is the use case view. The use of a system is illustrated using a set of use cases. The use cases describe interactions between actors of the system and the system itself. In a way, the use cases are used to scope the system and to identify which interfaces there are or should be with external systems. Sometimes, people also include scenarios as an elaboration of use cases. These scenarios illustrate the behavior with a focus on interaction between components. Such scenarios can also serve as a starting point for creating tests for the system. Different stakeholders have different interests in a software system. And some aspects of a system are relevant to developers, such as the system structure. Others are relevant to system administrators, such as how to build or configure or where to install. The developers want to know about things like classes, and system administrators want to know about deployment, hardware and network configurations and don't care about classes. Similar points can be made for testers, project managers and customers. This slide shows that different views offer information that caters for different stakeholders. This slide shows the various types of diagrams that are actually used for describing the various views. We can see structure diagrams, behavior diagrams, use case diagrams, deployment diagrams, as well as a mapping of conceptual components onto files. It is rare that a project will have enough time to model every single diagram as detailed as possible. Architects need to prioritize different views. For example, for a business domain intensive project, it would make sense to prioritize the domain model. In a project with high concurrency and complex timing, it makes sense to ensure that the process and real-time view gets enough attention. The 4+1 approach was put forward 2 years before the first introduction of UML, which appeared first in 1997. By now, there is an international standard for UML, and currently this standard defines UML 2.0. UML 2.0 has 13 different types of diagrams, and each of these diagrams can be mapped into one of the 4+1 views. In this lecture, we have referred only to several diagrams, which are the most commonly used ones. And since its introduction, UML has become the default language in companies for modeling software systems. By now, we have shown that for describing each of the views of an architectural description, multiple complementary diagrams can be used. This slide shows an overview of this. The lecture documenting software architecture with views in UML Part 1 is finished. Thanks for watching, and we hope to see you in Part 2.